Hey everyone, going to go through a quick volume problem here for Calculus 2. Apologize in advance for some of the shaky taping, but we'll try and do our best here. So let's look at the question. Find the volume of the solid generated by rotating the region bounded by y equals root x and y equals x squared around the y-axis. So a lot of information there. Let's try and walk through it. So the important part is kind of that region that we have to find first. So it's bounded by y equals root x and y equals x squared. So let's try and graph those right now and see if we can kind of come up with what the picture is going to look like. So let's do a quick graph here. And I know that y equals root x is kind of going to look like this. If you don't, you can use the table of values. And I know that y equals x squared kind of looks like this, right? It goes up very quickly. And this point where they're going to meet, if you can't figure that out right now, you can kind of use some algebra, but the point is 1, 1. Right, so here's kind of the region that they're talking about, the shaded area here. And it says we are rotating it around the y-axis. So, excuse my poor drawing, but I'm going to try and draw basically what we'd call a washer here, if you've done some homework questions. So the reason it's a washer is because there's going to be this hole in the middle. As we rotate around here, there's kind of this outer radius and the inner radius. Again, sorry about the poor drawing, but you can see that the volume of this, I just drew one of these washers in, but we're going to do this at all levels, and they'll be smaller towards the bottom and bigger towards the top. And then ultimately you're going to end with kind of this volume, this kind of cone or bowl shaped figure that's going to have some sort of volume to it. So we need to figure out what that volume is. So we know, hopefully you've done some of these problems, that volume, we'll say it equals the integral because we have these sort of two circles with an outer radius and an inner radius, we'll say it's the area of those two circles subtracted from one another times dx. So area of a circle is pi r squared, so pi I'll call our outer radius squared minus pi r inner radius squared. And then normally this would be dx, but in this case we're rotating around the y-axis or a vertical line, so we actually want to do dy. Now that's really important to remember. If we're rotating around a vertical axis, we'll call it dy. Rotating around a horizontal axis like the x-axis, we'll call it dx. And so now we need to get these, because we have dy here, we need to set up our integral from the lowest y value to the highest y value. In this case, it's going from, you look at the 2 points of intersection, so 0, 0 is one, and 1, 1 is the other. So I'm going to say this is the integral from 0 to 1. Okay, so that's where we are right now. Now we need the radius in terms of y as well. So right now we've been given y equals root x and y equals x squared. We need those functions in terms of x equals g of y. Right now we have them in y equals f of x. We need them in terms of y so that we can substitute those in for the radius. Because if we look at the picture one last time, the outer radius is always sort of the x value. So the distance from the y-axis to the outer curve is x. The distance from the y-axis to the inner radius is also x, but they're on different curves, right? So we've called this curve y equals root x, and this curve y equals x squared. Now all we have to do is solve for x on its own so that we'll have a function of y, and that'll be the radius. So let's just quickly do that. Y equals root x. That's the same as x equals y squared. I've just squared both sides there. And y equals x squared is the same as x equals root y. Fair enough. So now we can use these two here as our, if we look back at the picture, we know that y equals x squared was the outer radius here. So x equals root y will be the outer radius. X equals y squared will be the inner radius, and we can go ahead and solve our integral. So we have the volume equals, we had from 0 to 1 of pi, I can pull the pi out to the front. So we have pi, the integral of 0 to 1. We want outer radius squared minus inner radius squared. We said that outer radius is root y, so root y squared minus y squared squared dy. Sorry. Okay. Okay, so now we can go ahead and simplify before we solve the integral. So it's pi integral from 0 to 1 of root y squared is just y minus y squared squared is y to the 4 dy. Now it's a simple integral. Don't forget your pi out front. We'll say it's y squared over 2. That's how you integral the integration of y minus y5 over 5, and that's evaluated from 0 to 1. This is pretty simple. We have pi into 1 over 2 minus 1 over 5, and that equals 3 pi over 10. So that's the volume of that solid that we drew there. Couple key points. Remember, a vertical axis that you're going about, whether it's the y-axis or a line like x equals 2 or x equals negative 5, that is a vertical line. We want to get our functions x in terms of y so that we can use a function of y as each of our radius. And then just got to remember that when we're dealing with washers, it's the outer radius squared minus the inner radius squared all times pi. Hopefully that was pretty clear. Sorry about the rough taping. Please email us if you have any questions at all. Thanks.